In this recording, we're going to look at quartiles, and I want to go ahead and start with this example where we've got the tornado data from the last example. We've got it here. Before we get to that one though, let's do a really simple list of data. So I've got an extra sheet of paper here. Let's say that we've got just this really simple list of data, 1, 2, 2, 5, and 7. And we want to break this up into groups of 25%. So our quartiles take the data and break it into groups of 25%. This is a small data set, so it's a little bit funny, where the percentiles worked off of 100%. So as I'm looking at this, what I want to do first is to take my data and divide it in half. Well, in order to divide it in half, I need to go right through that number 2. Well, 2 is the median, and that median is actually the second quartile. As soon as I've divided it at the median, I'm not quite 2/4, but I'm at 50% on either side, and we just pretend like we split that 2 in half. So I've got 2 split in half. I go ahead and I take the rest of the data and I figure out what I've got left from here. Well, in order to do 25%, there's a couple things I can do. I can do this manually. Let me show you how to do this with your calculator, and then we'll confirm the result with the calculator. So I'm going to go into Stat, we're going to go Edit, and I'm going to put this data into L1. So I'm going to clear what's in L1, enter 1, 2, 2, 5, 7. I'm going to run one variable stats. I'm using the older operating system. So when I do calc, it says one variable stats for what. If you're prompted for your list, you're going to make sure that L1 is in the list name and frequency is blank. And then I scroll down. Here are the values that we've used so far. We've got a minimum of 1. Starting with the minimum, this is my 5-number summary. The minimum is 1. The quartile is 1.5. Median is 2. Quartile 3 is 6. So you can take a look and see exactly what they did to come up with the other quartiles. They took the data that was remaining, the 5 and the 7 up on top, and the 1 and the 2 down below, and they split those in half. Well, as I split those in half, I end up landing right in between 1 and 2. So this gives me 1.5, so 1 plus 2 divided by 2, right in between would be 1.5. This is quartile 1. And right in between 5 and 7, that gives me quartile 3. Right in between 5 and 7 would be 6. Or you can average those. 5 plus 7 divided by 2 is 6. So if we were to do our 5-number summary, it looks like this. The 5-number summary, I start with the minimum. So the minimum is 1. Quartile 1 is 1.5. The median, also known as quartile 2, is 2. That's the number right in the middle of all the data. Quartile 3 is 6. I've got 1, 2, 3, 4 values so far. We finish off with the maximum, and the maximum is 7. So this is the 5-number summary. The quartiles are really easy to compute using the calculator, and that's exactly what I'm going to do with this example that we started off with number 2 in our tornado data. I already have that data entered into my calculator. Just to verify that it's still there, I'll go into Edit, and it is still here. I organized it ascending in the last video, and I'm just going to go ahead and leave it that way. It doesn't matter if it's in order or not, just as long as all your data is in one of your lists. Since mine's an L2, when I go over to my home screen and Stat, I want Stat, Calc, one variable stats, I'm going to type in L2 instead of L1. I hit enter, and I'm looking for that 5-number summary. So I scroll down and I find the minimum. This particular question only asked me for the quartiles. So, let me put it up here actually. Let me move this out of the way so we can list those quartiles. So the quartiles are, so quartile 1 is 29.5. The median is a quartile. That's quartile 1. The median is quartile 2, which is 123. Quartile 3 is 135.5. So as I look at my data, and I'm not going to write it down because there's a lot of it, but as I look at my data, 123 splits my data into 50% portions, so 50% below 123, I mean roughly, right? 50% above. Quartile 1 and quartile 3, that's at 29.5 and 135.5. Those quartiles break my data into groups of 25%, 25%, 25%, 25%. Quartile 1, quartile 2, quartile 3. We call this range right here, and I'm just about making a box plot. Actually, I pretty much do have a box plot. We call what I've boxed in red here the interquartile range. Interquartile range. Interquartile range is between quartile 1 and quartile 3. So if we compute how big that is, quartile 3 minus quartile 1, I'm just going to subtract 135.5 minus 29.5. I'll just cheat and do it in my calculator. 135.5 minus 29.5, and I get 106. This is another way of describing 50% of the data. So 50% of the data lies within a range of 106. The question had one more task for us, and that was to check for outliers. I've got this interquartile range right now, so my I, Q, R is 106. If I check for outliers, I'm going to take quartile 1, and I'm going to subtract 1.5 of my interquartile range, and I'm going to do something similar with quartile 3. I'm going to add 1.5 of my interquartile range. So as I'm checking for outliers, I'm going to take quartile 1 minus 1.5 times the interquartile range. So I'm just writing it in general. For our data, quartile 1 was 29.5 minus 1.5 times 106. Okay, in my calculator, 29.5 minus 1.5 times 106. That gives me negative 129.5. I would need data below negative 129.5 in order to have an outlier on the left. Okay, let's do outliers on the right. Okay, so the other outliers, which are going to live over here, that would be quartile 3 plus 1.5 times the interquartile range. So I need just to adjust this. Quartile 3 is 135.5 plus 1.5 times 106. Okay, so 135.5 plus 1.5 times 106 gives me, I'll put it right here, 294.5. So I would need a month that had more than 294.5 tornadoes in it in order to have an outlier on the right. Outliers. Okay, so let's look at our data. We definitely don't have any less than a negative number. These are a number of tornadoes, so they're all positive numbers. We want to know if we have any months where we have a number of tornadoes greater than 294.5. And we do. And if you look at your data, 3310, those are kind of little, but the others are in the hundreds. 316 is really big compared to the rest of the data. So this one, that 316, is an outlier because of that formula. So that formula, again, we want to know if there's anything smaller than quartile 1 minus 1.5 times the interquartile range, or anything that's bigger than something similar, but we're going to add that value to quartile 3. Okay, so that takes care of that one. Let's do another. Oh, and actually, if you look at your next page here, Quartiles and the Boxplot, we just finished one part B. So let's go ahead and just write our values in for one part B. I can grab that minimum, that was 10. Quartile 1 was 29.5. The median is 123. Quartile 3 was 135.5. The maximum was that 316. And the interquartile range, which was quartile 3 minus quartile 1, was 106. So that finished part B for us. Let's go ahead and do number 1, part A. So it's asking me to do the same thing. I'm looking for that 5-number summary. I'm going to use the calculator. Stat, edit, I'm going to delete L1 and type my values in. So I've got 8, 12, 32, 6, 27, 19, and 54. Let me double check. 27, 6, 32, 12, and 8. So I'm going to run one variable stats, calc, one variable stats on L1 this time. And I can grab everything but the interquartile range off of my calculator. Okay, so the minimum, if I arrow down, I start finding that 5-number summary. The minimum is 6. I need more room to write. The minimum is 6. Quartile 1 is 8. The median is 19. Quartile 3 is 32. The maximum is 54. It does not give me the interquartile range, so I'm going to go ahead and compute that. But I know that the interquartile range, IQR, is quartile 3 minus quartile 1. So that is 32 minus 8. So what would that be, 24? 24. Okay, so we've got the 5-number summary plus the interquartile range. Next, we're going to construct a box plot. I was really close to a box plot in that last example. Let me go ahead and do a formal box plot, though, for this one. My scale along the bottom is just a regular number line that's going to include these numbers. So I need spaces for 8 through 54. So if we call this 0, I'm just going to go 10, 20, 30, 40, 50, 60. Okay, so 10, 20, 30, 40, 50, 60. My box goes from quartile 1 to quartile 3. Quartile 1 is 8. That's going to be the bottom of my box. Quartile 3 is 32. That's going to be here. I draw the box from quartile 1 to quartile 3. The median, which is 19, is a line in the middle. And the way we do our box plots, there's different ways, but the way that we do it is we go down to the minimum, which is 6. And these are called the whiskers, and then up to the maximum, which is 54. 54. So again, I've got the minimum. This is my 5-number summary. The minimum, quartile 1, median, or you can call that quartile 2, quartile 3, and then the maximum. Check for outliers. So let's go ahead and check for outliers on this one. In order to have an outlier, I need quartile 3 plus 1.5 times the interquartile range. Anything above that, or quartile 1 minus 1.5 times the interquartile range. Okay, so let's compute these. I'm running out of room, aren't I? Quartile 3 is 32. 32 plus 1.5 times 24. So 32 plus 1.5 times 24. So that would be 68. So 68 lives over here, right? So anything beyond 68 would be an outlier. I don't have anything beyond 68 in my data. And then on the other end, quartile 1, so that would be 8 minus 1.5 times 24, so 8 minus 1.5 times 24, that would be negative 28. And I didn't have any negative values. Negative 28 would be way down here. Negative 28, somewhere down there. So those outliers on the left-hand side would be way, way over here. I don't even have enough room to write them. I don't have any outliers because nothing lies above 68 or below negative 28. Okay, so part B, we also want to do, what did we miss on this one? We want to do the box plot. and we also want to check for outliers. So let's go ahead and do our box plot first. My minimum is 10, my max is 316, so I need a pretty generous scale here. So let's go ahead and just do this in 50s maybe. So we're going to go 50, 100, 50, 200, 50, 300. So this would be 50, 100, 50, that would be, sorry, 150, 200, 250, and then 300. Okay, so as I put my box plot together, I need quartile 1. I'm just going to ballpark it. That'd be 29.5, so roughly here. Quartile 3 is at 135.5, so roughly here. I'm going to go ahead and construct my box. My median is at 123. Look how close those two are. At 123, which is over here. And then I'm going to go up to my maximum, which is over here, down to my minimum, which is here. So again, 5-number summary. Minimum, quartile 1, median, quartile 2, and then way over here is that maximum. We've already checked for outliers on this one, so let me just remind you of what we've got here with the box plot. The box in the middle represents the middle 50% of my data. So this is fairly typical tornado data. So the middle 50% is there, the 25% between the minimum and quartile 1, and then the upper 25% and this huge range between quartile 2 and the maximum. Okay, let's go ahead and take a look at number 2. Number 2, so you're going to see this in your homework. Number 2 actually starts us backwards, so it gives us a box plot to start off with, and it asks us to identify the quartiles and the minimum, maximum, median, and the interquartile range. We're going to ballpark these. This is actual data from my class a quarter ago. These are credits total, so the credits total that each student had taken, including that quarter. So when I just ballpark these, I'm going to write these with a pen, and then I'll write in the real values here in just a second. It looks like that minimum is maybe around 18. Let's see, quartile 1. So quartile 1 would be about right here, maybe at right between 40 and 60, so about 50. The median looks like it's right around 70, maybe a tiny bit more than 70, 71. It looks like between 100 and 1, it's like 110 for quartile 3. And my maximum is somewhere over there, I don't know, maybe 172. Let me give you those actual values. So I computed these before I started the video. The actual minimum credits total was 19. Oh wait, let's see, that's the wrong list. It is, how would I put it? I'll find it. Oh, here it is. Okay, the actual minimum was 15. The actual minimum was 15. Quartile 1, we had that one right at 50. The median, we had that one right too at 71. Quartile 3 was correct at 110. The maximum was really close. We would never have guessed that, 173.5. The homework questions, they line up so much nicer since I used real data from that class. I thought I'd just give us the values since they didn't line up super nice. Let's find that interquartile range. Interquartile range is quartile 3 minus quartile 1. So 110 minus 50, which is 60. We can look for outliers, or at least identify where those outlier ranges would be. So in order to find an outlier, quartile 1 minus 1.5 times 60. Quartile 1 was 50. So I would take 50 minus 1.5 times 60, and we get negative 40. No one's going to have any credits that are less than negative 40. So that would be the low. And then the max would be quartile 3, which is 110, plus 1.5 times 60. So 110 plus 1.5 times 60, we get 200. So that upper boundary would be 200 or more. We already identified that the maximum is 172, so we're not going to have any values that are above 200, so we can say that there are no outliers in this data. I've got one more box plot for you. In this last box plot, you'll see that the program that I'm using does the box plot just a little bit differently. I'm not going to explain it. What I want to do instead is to talk about the 5-number summary for this one. Notice how it gives you a dot. So it identified the maximum as an outlier. And it uses the interquartile range to come up with this one. It takes like half the interquartile range or something like that. I'm not going to focus on it, but it puts a dot here to identify the outlier, which is kind of interesting. The other interesting part about this one, these are my students' ages from a quarter ago. There's no stem on this part. There's no whisker. Well, that tells me that the maximum is equal to, oh, not the maximum, the minimum is equal to quartile 1. And it looks like it's right about 18. And again, I've got this data here. Here it is. Oh, it's 19. So the actual value is 19. Again, on your homework, it'll be a lot more obvious. With real data, it's a little bit tougher, so I brought the actual data. The minimum is 19, and the quartile 1 is 19. What that tells you about your data is that you've got a lot of 19-year-olds in your class. And I had a ton of 19-year-olds. Strangely, no 18-year-olds to skew that a little bit. So the minimum and quartile 1 happened to be the same. So you just don't draw a whisker on that end. And it looks like the median is right around 22 or so, and it turns out to be 21. So that would be my median right here. Quartile 3 looks like it's maybe 29, and it is exactly 29. And then the maximum is this value right here, which is 46. Let's go ahead and do that interquartile range. So the interquartile range is 29 minus 19, which is 10. To find the boundaries for the outliers, I would take quartile 1, which is 19, minus 1.5 times 10. So what that'd be 19 minus 15, right? That'd be 4. There are no students who are less than 4 years old in my class. For the upper, so this would be the lower boundary. The upper boundary for outliers would be quartile 3, so 29, plus 1.5 times 10. So that'd be 29 plus 15, which would be 44. So my outliers, here's 4, live less than 4 or greater than 44. Our maximum value of 46 is an outlier because it's outside of 44. So we do have an outlier in this case, and it's that 46. I thought it was interesting how my computer program notes that as a dot, but in your textbook you would just draw the line all the way up there. So I'm going to go ahead and say that we do have an outlier at 46. Okay, and that does it for the quartiles and box plots.